Okay. Now guys, today we'll study OSPF. So you can write the heading OSPF, or it's called Open Shortest Path First. Open shortest path first. Okay. Now guys, now let me tell you. Okay, guys, it's okay, right? Okay. Now, so OSPF, it's an open standard protocol. It's an open standard protocol. Okay, it's an open standard protocol. Yes. It comes under the family of link state protocol. Link state protocol comes under the family of link state protocol. You just started. Okay.
Usually started 5:30.
Okay. So just thought to start before 1 minute. Okay. Just started this.
Yeah.
Just mentioned. Okay. So it's an open standard protocol and it's link state protocol. Okay. Now it's called link state protocol because it works on the status of the links. Okay. So that means it sends the updates. It sends the updates when a link state failure occurs or a link state change occurs. If the interface becomes up or if the interface becomes down, then this information or the update will be shared. Okay, and that's why it's called link state protocol. Okay, now OSPF, it runs an algorithm called SPF algorithm. SPF algorithm, or it's also called Dijkstra's algorithm. Dijkstra, Dijkstra's algorithm. SPF algorithm or Dijkstra's algorithm. Okay, SPF means shortest path first algorithm. Okay, now the metric used by OSPF is called cost. Yes. Okay. So the metric used by OSPF is called cost. Cost is the metric. Cost. The metric used is called cost. C-O-S-T. Cost. Okay. Now, the cost is calculated by using a bandwidth. Sorry, by using an equation. The cost is calculated using an equation. So the equation is reference bandwidth divided by interface bandwidth. Reference bandwidth divided by interface bandwidth. Yes, please.
So cost is calculated by using
An equation or a formula or equation. Okay, and this is the equation. Cost is equal to reference bandwidth divided by interface bandwidth. Okay. Yes. Normally the reference bandwidth is a constant which will be 100 Mbps. So 100 Mbps divided by interface bandwidth. That's the cost. So let me ask you guys, what is the cost of Ethernet interface? Ethernet interface. What will be the cost of Ethernet interface? 100 divided by 1 or 2. 100 divided by what is the interface bandwidth, guys? What is the bandwidth of Ethernet interface? What is the bandwidth of Ethernet interface?
gigabyte or something.
1 gigabyte Ethernet interface. So what is the bandwidth of gigabit Ethernet interface? 1000, or it's 1 Gbps. Okay, so now Ethernet interface has a bandwidth of say 10 Mbps. So 100 Mbps divided by 10 Mbps. So what will be the answer? 10. Not even 10. It's just a number. Not even Mbps. It's just a number. 10. So this is the cost of Ethernet interface. Now the cost of fast Ethernet interface will be 1. The cost of fast Ethernet interface will be 1 because 100 divided by 100 will be 1. For serial interface, cost is equal to 100 divided by the bandwidth. The base bandwidth of serial interface is 1.544 Mbps. 1.544 Mbps. So it is 64. It is around 64 or 64 point something. We will take the value 64. Clear, guys? This is how they will calculate the bandwidth. Sorry, the cost. Okay. Now, OSPF maintains 3 tables. OSPF maintains 3 tables: neighbor table, topology table, and routing table. Neighbor table, topology table, and routing table. Neighbor table, topology table, and routing table. Okay. Now, so here, let me tell you the process here. OSPF process. Okay. So OSPF process is something like this. Suppose 2 routers are enabled with OSPF. So R1 and R2. R1 and R2. Say suppose they are connected. Suppose this having IP 10.0.0.1 and this having IP 10.0.0.2/30. Let it be. Okay. Now what they will do is that, say suppose R1 has got a network 20.0.0.0/24 and R2 has got a network 30.0.0.0/24 network. Okay. Now first what R1 will do, or these routers will do, is that they will send certain hello packets. They will send certain hello packets. So the hello packet is sent. Hello packet is sent. So R1 will send the hello packet to R2. Suppose R2 has received it. R2 has received it, and R2 sends another hello to R1. So R2 has received it, has seen it, and is sending back another hello. Okay. So when, now just give me a moment. Just a minute, guys. So suppose this is (20.0.0.0/24). Okay. So now let me come back. Say if when R1 sends the hello, it will be in init state. It will be in init state. Okay. Now when R2 sends back a hello, then it is called two-way state. It's called two-way state. Okay. So that means, say they have exchanged the hello and they have formed the, say, neighborship. They have formed the neighborship. So this is where they will form neighborship. Clear? Now the neighborship has formed. Okay. Now let me tell you what they will do. Now R1 will send certain packets. R1 will send certain packets. R1 and R2 will send certain packets. Okay. OSPF related packets. Now, so they will start sending DBD. They'll start sending DBD. DBD means database description. Database description. Database description means, let me tell you. So R1 will tell, say like this: hey R2, I know a 20 dot network. Do you know about it, or do you want to know about it? Clear? It is the database description. It's a small or a brief detail of the network. Okay, so it is saying I need, or I have, or I know a 20 dot network. Do you need it, or do you want to know about it? Clear? Okay. Then what R2 will do is that if R2 doesn't know about the 20 dot network, he will request it. He will request it. So he will send something called LSR. He'll send something called LSR, or LSR is called link state request. Link state request. Link state request. Or guys, I'll give you time to write. Okay, I'll give you time. Okay, so it's not yet finished, that's why. So R1 will send a DBD, database description, and that is called xstart. Xstart state. Exchange has started. Okay, xstart state. And the next is called exchange. Exchange state. Exchange. Okay, now the next one is called, say the next state is called loading. It's called loading. Loading means they will send, so he has requested for the link state request, or he has requested the about the network. R2 has requested about the network. So what the router will do is that he will send LSU. It's called LSU, or link state update. Link state update. Link state updates. So that is called loading. Okay. Now once the update, so the update is where, say, or the LSU is where they'll send the network related information. Okay, or the 20 dot information. So 20.0.0.0/24 can be seen there. And so if at all he has updated and he has received it, this guy will acknowledge back. So that's called LS acknowledgement. That's called LS acknowledgement. Okay, so now what happens is that this state is called full state. So after this state, or after sending this acknowledgement, it's called full state. It's called full state. So full state is where you will tell they have formed adjacency. They have formed adjacency. Clear? Any doubts? Okay, so these are the OSPF state: init, two-way, xstart, exchange, loading, full.
So
Okay.
this is the request sent from R1 to R2. So similarly from
Yes, from R2 to R1 also it will be sent. These things will be sent. Okay. Now, so these are the OSPF states, and these are the OSPF messages, or the OSPF packets. You got hello packet, DBD, LSR, LSU, LS acknowledgement, etc. Okay. Yes. Now let me again tell you. So after sending the hello, these one. So I told you they will form the neighborship. They will form the two-way state and they will form the neighborship. So if when the neighborship is formed, the neighbor table will be updated. Okay, so in R1's neighbor table, we will have R2's information. In R2's neighbor table, we'll have R1's information. Okay. Now, the next is called topology table. It's called topology table. So the topology table contains all, so these messages are called LSA. Those messages are called LSA. Link state advertisement. Link state advertisement. Link state advertisement. Link state advertisements. So whatever link state advertisements that you send will be in the topology table. Okay, so that means R1 and R2 both will have the same topology table. Okay, so you can say in the OSPF, all the routers in an area will have the same topology table. Okay, now what the routers will do is that the routers will calculate the SPF algorithm. The routers will calculate the SPF or run the SPF algorithm, and then will place the best route in the routing table. Always the best route will be there in the routing table. Okay, so this is how the OSPF is working. Clear? Any doubts? Okay. So now we'll be studying some more things. Okay, now let me tell you area concept in OSPF. Area concept in OSPF. Okay, let me tell you an example. Suppose this is our classroom. This is our classroom. Or suppose we got this is our classroom and we got students. Say this is CCNA classroom. Or suppose class 8, standard 8. Suppose you are studying in standard 8. Okay, so you got students here and we got students. Suppose these are those last guys. Okay, so this is, say, Salman. Yes. If you don't come, then I'll forget the faces.
I got it.
Okay. Now, so this is Susmit. Okay, and this is Sajin, and this is Ashwin. Yes, Ashwin, and this is Anish. Okay, so we are in class 8. Not we, you guys are in class 8 now. Okay, suppose Anish has won not Anish. Okay, suppose Anish, yesterday I told Anish as the example. So suppose Sajin. Okay, Sajin has won a lottery. He has won a lottery. Okay, then what Sajin will do? So, or everyone will congratulate him. Everyone will congratulate him. Oh, you have won the lottery, you have won the lottery, you have won the lottery. Everyone say. So here Sajin, say suppose he has won the lottery. Accidentally he told it to Anish. And what Anish did is, Anish again told it to everyone. Anish told to everyone. Okay, so then everyone came to know about that. That means everyone in that, say, classroom came to know about this Sajin. Sajin has won the lottery. And what is the problem? Sajin will have to give the treat. Right. So, suppose that, say again, so going with another example. The issue is that everyone needs to congratulate him. Okay, or everyone, say, they need to like reset their stomach and next day they'll have to come. Right. Okay, so it is, and that's a problem for Sajin as well. Okay, now, so suppose if you have got 10 students or 20 students or 30 students. Okay, so everyone will come to know about it and everyone will be asking for the treat and everyone will be ready for or getting ready for the treat and all. Okay, but let me tell you. So suppose if you got 30 students are there, he'll have to give treat to all the 30. Okay. Now, if suppose 15 people are in one classroom, 15 people are in one classroom, and the other 15 people are in other classroom. Okay, suppose the same, say Salman, say here Salman, say Susmit, Sajin, Ashwin, Anish. Okay, all are in the same classroom. Now Deva, say Satish, Vaman, and all. Okay, so they are in the next classroom. Okay, so let me tell you. So here what happens is that everyone in our classroom, right, everyone in Sajin's classroom will congratulate him, and Sajin is giving treat for them. Okay, but so for Deva, Satish, and Vaman, they are in another classroom. Okay, yes, so they are in another classroom. So if at all they are in another classroom, let me just tell you, so here they shouldn't be congratulating, or they just met Sajin. So these are not best friends, they are not just best friends, they are just seen Sajin. Okay, so just they need to know, or they will hear about Sajin. Yes, Sajin has won the lottery, and Sajin also don't have to say give treat to them, because those are like in a different class. Getting it? Now coming to OSPF. So suppose you got different routers. You got different routers. Okay. Now, if you got different routers here, say suppose R1, R2, R3, R4, R5, R6, R7, R8, R9, etc. Okay. The problem with the OSPF topology is that in case, so I told you it is a link state protocol. It's a link state protocol. So if at all the link, say suppose 10.0.0.0/24 link fails, or if at all the link comes up, the routers will have to calculate the SPF algorithm. Routers will have to calculate the SPF algorithm. Okay, so R1, R2, R3, R4, R5, everyone will have to recalculate the SPF algorithm. So recalculating the SPF algorithm is, say, an overhead for the routers, because he's already performing packet forwarding. He might be processing EHRP, he might be processing BGP, he might be processing some other things, many things, of which again rerunning the SPF algorithm. SPF is, say, not a simple one. So rerunning the SPF algorithm is again complication. So every time if you want to rerun the algorithm, that's going to be a problem for them. So what happens is that, or to make the reduce the complexity, what we will do is that we will split it into two area. We'll split it into two or more area. Okay, so here suppose you got 30 people and we divided into 15. So here also suppose here there is one area. Okay, and this is in another area. This is in another area, and this is in another area. So if at all the link comes up, or if at all this link goes down, let me tell you what happens is that, Satish, what happens if the link goes down? Yes, something happens, right? Okay, you can also let it happen and then come back. Fast. Watch the face. Okay. Anyone feeling sleepy? Sure. Okay. Guys, if you want to turn it off? No. Okay. Salman? Okay. So guys, just a moment, let him come. Yes, Susmit.
What is full form of cost?
What's the full form of? Host. Cost, I suppose it doesn't have any full form. It is just a metric. It's a value. It's a number. So did I tell you about my faculty? No. So when I was studying MCSE, another course, okay. So what my faculty used to do is that if at all I sleep, I was a usual student who sleeps at 2 p.m. class. Okay, usual student who sleeps at all the 2 p.m. class. So what he used to do is that he used to make me stand up. Okay, he used to make me stand up and then say write the notes. Also that he he used to like ask questions. Okay, and the last thing that he did was hmm? No. We don't have girls in that class. So you are very happy.
Yeah, it's always happy when it comes to girls.
Yeah, EHRP will, but the working is different. EHRP also maintains 3 tables, OSPF also maintains 3 tables, but the working is different.
ERGIP depends upon K value.
EHRP will calculate the values based on the K values. But here you got an equation. There also you got an equation, a lengthy equation. 10 raised to 7 divided by least bandwidth into something like that. Okay.
Didn't say yesterday, sir.
Didn't say yesterday. You can search it. Okay. It's not necessary at the moment. Okay. It's something like 10 raised to 7 divided by least bandwidth. Even forgot into some values and all. Okay. So now guys, now coming back. So what we have done is we have divided the OSPF topology into multiple area. Okay, multiple area. So here let me tell you, say suppose if this is the figure. Okay, so suppose this is an area. Okay, this is one area. This is another area. And this is also another area. Okay, so this area, it can be area 1 or area 2 or something. Area, say, or area 10. Let this be area 0. Area 0. And let this be area 200. Area 200. So the advantage is that if at all the link goes down or the link comes up, all the routers, which all routers, R1, R2, R3, R4, R5, only all the or only these routers need to rerun the SPF algorithm. Okay, these routers will rerun the SPF algorithm. And again, let me tell you. So yes. Sorry. So if at all the link comes up, then R3 and R5 will rerun the SPF algorithm. All these routers will rerun the SPF algorithm, and R3 will send it to the other area. So the routers in the other area, they shouldn't, or it's not necessary for them, or they won't be running the SPF algorithm here unnecessarily. Clear? Okay. So that is how OSPF, and that is why we have divided the area into multiple, or the OSPF topology into multiple area.
So those routers will be part of both the area.
Yes. So these routers R3 and R5 are now part of 2 area. Okay, it is part of area 10 as well as part of area 0. So the router which is participating in 2 area is called ABR, area border router. Area border router. Area border router. So these are also area border routers. R6, R7. Okay. Now, so this is the ABR. Now let me tell you, this area 0, this area 0, this area 0 is called the backbone area. It's called backbone area. Backbone area. And other area, say area 10 and area 100, are called non-backbone area.
Why it's called a backbone?
Because it is mandatory for an OSPF. So let me tell you, for humans, say the most important thing is the backbone, spinal cord or whatever, the backbone, those things and all, right? So if it is damaged, means say then you won't be able to stand up, right? So everything is gone. So similarly, so here the backbone area is called backbone area because it is mandatory. So in an OSPF topology, area 0 is mandatory. And let me again tell you, if you are connecting another area, it should be directly connected to area 0. So the other area should be connected to area 0.
How do we connect which with the backbone?
So area 0 is configured as the backbone itself.
All the time.
Okay, all the time. So if it's area 0, then it acts as the backbone. Okay. Now, so this is the OSPF thing. Now we'll go to one more thing called wildcard mask. Then we'll move on to the config. Okay, so you can write the heading wildcard mask. Wildcard mask. Wildcard mask. Okay, so let me tell you what this is, wildcard mask. Okay, so now for now just understand, it is just the opposite of subnet mask. It is just the opposite of subnet mask. So in subnet mask, we have written the network portion using 1, and we have written the host portion or the host bits using 0. If it is just the opposite of subnet mask, then let me tell you, wildcard mask means all the network bit will be 0. All the network bits will be 0, and all the host bits will be 1. Clear? Okay. So this is how you will write the wildcard mask. Okay, yes. Now, so let me tell you, if you have a network like this 10.0.8.0/24, so how to find this wildcard mask? Okay, so first you will write the subnet mask. So what is the subnet mask here? 4/24 255.255.255.0. So, and you can find out with two methods. You can say if /24 is there, 24 zeros will be there. That means it will be 0.0.0.255. So 24 zeros will be there because network portion will represent using zeros. So 24 zeros will be there. Satish,
Yes, sir.
getting it?
Yeah.
Okay. Now say 8 host bits will be there. 8 hosts. So 8 ones will be there. So 8 ones will become 255. So that's how you have got it. Or let me again tell you, if at all you want to find out the wildcard mask, and suppose you know the subnet mask, then you can decrease it from this number. So this number is 255.255.255.255. Sorry. Okay, so you can decrease the subnet mask from this value. Okay, so the subnet mask is 255.255.255.0. So 255 minus 0, 255 minus 0, 255. Now 255 minus 255, 0. Again 255 minus 255, 0. Again 255 minus 255, 0. So this is this 255, guys. This is how you have got the wildcard mask. Clear? Either you can do it in the first method or you can do it in the second method. Now
So why
Now-
do we need a wildcard mask?
because it is there in the command syntax of OSPF. Okay, subnet mask is not mentioned, but the wildcard mask is mentioned. Okay. Later you will study it is used to group the computers. Later you will study that. Okay. Yes.
It's connected in a group like.
We will study it later. Okay. Now done. Sorry. So now let me tell you. So if at all I give you some questions, I suppose you can do it. Okay. So let me give some questions to you so you can calculate. 58.158.250.0/24. 100.108.116. Say 28/25. Now 15.1.2.0/23. Then 100.1.2.0 or 2.24/30. Now 150.180.180.160 slash sorry, just give me a moment. It's 160.0/90. Now 8.48.0.0 slash 9 40. Can you try to do it? Okay. Yes. Okay, so the wildcard mask for the first one is 0.0.0.255. Okay, and say second, Selva will answer this. Selva, can you answer the second one? Okay, now, so again, let me pause recording. Okay, so now the next. So Rakesh, can you tell me the second one?
Sir, for second one, it is 0.0.0.127.
0.0.0.127. Okay, yes. Now, what will be the third one? Who will tell? We got Rakesh. Subhash, can you tell the third? Yes. Very good. It's /23. So it is 0.1.2. 0.0.1.255. Okay, so 0.0.1.255. Thank you, Subhash. Now we got Varman left. So Varman, can you tell me say this one, the next one? 0.0.0.3. Okay, 0.0.0.3. Okay, now who will tell in the offline class? Who will tell the next one answer? Yes, Salman. 0.224. Let me check. 19 plus 3 is 24. No, 19 only. Right. 16 and 3. Okay. 128 plus 64 plus 32. Okay, that is right. But let me tell you, it is 16. Okay, so that is 0.0.220. It's even not. That is also not 224. Okay, 0.0.31.255. Opposite. Okay. Yes. So yes, 127.255. Rakesh, that is unfortunately yours is wrong. Okay, so I suppose now you might have got it. So 19. Okay, 19 bits will be reserved for say network. So that means 19 zeros will be there. Okay, so 19 zeros, and how many ones will be there? Say, or host, how many host portion will be there? 32 minus 19. So 12, 3, right? Okay, 30. 13 will be there. So if you make 13 ones there, you're gonna get this one. Okay, 0. Okay, 31.255. Understood, Rakesh? Okay, I suppose you have understood that. Okay, now the next one. Okay, once again. Okay, let me just tell you, because he has asked for once again. Nothing. Okay, Rakesh, it's simple. So let me tell you, 19/19 bits, 19 bits are reserved for network. So 19 zeros will be there. 1, 2, 3, 4, 5, 6, 7, 8. Dot. 9, 10, 11, 12, 13, 14, 15, 16. Okay. Now 17, 18, 19. Okay. Now 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So here it will be 0 dot. Here also it will be 0 dot. And here it will be 1, 2, 4, 8, 16. When you add everything, you're going to get 31 dot, and this one is 255. So that's how you got 0.0.31.255. Now clear? Okay. Now what will be this one? I mean the last one. Who will tell the answer? 0 dot. Let me check. 14. Okay. So 8 plus how much is 14? 8 plus 6. Okay, so 2 bits. Yes, you are right. So 0.3.255.255. that will be the wildcard mask of the last one. Clear?
Reduce to 24 from 255.
Yes. Okay, you can do it in that method also.
Yeah.
Okay, that is, I suppose, that is the easiest one.
That was easy.
Yes.
First I calculate separate mask, from that I managed.
Okay, then you can go with that also. Say again, you need to find out the subnet mask for this one. So subnet mask will be, here it will be 255.14. So 6 bits are there. So if it's 6 bits, then I suppose it's 252.0.0. Okay, so this is the subnet mask, and this value subnet mask will be say reduced or subtracted from this value 255.255.255 minus the subnet mask 255.252.0.0. So this time it will be say 255 minus 0, 255 only. Okay, 255 minus 0, again 255. Say 255 minus 252, 3. Okay, 5 minus 2 is 3. Then 255 minus 255, 0. So 0.3.255.255. Clear? Okay. Now we will go to the OSPF configuration. Okay, so now just a moment. Yes, Satish, having doubt?
What's the guideline?
OSPF, nothing, just the configuration. Okay, just I told we'll go with the OSPF configuration, that's all. Okay. Just wait for 2 minutes, guys, because this will take time to load. Okay. In the meanwhile, okay, so now guys, now let me take, I suppose I might have saved the basic OSPF. Yes, OSPF basic. It's not there. Okay. Okay, so guys, this is the figure. So you got two networks. You got two networks here. Okay. So I suppose everyone can see, even at the back also, I suppose you can see, right?
Yes.
Okay. So now let me just give me one more moment. So you got 10.50.100.0/24 network here, and say in the, suppose this is the Bangalore branch. This is the Bangalore branch. Okay, this is R1 and this is R2. So R1 is in Bangalore branch, and we were discussing about Bangalore branch and Mumbai branch, right?
Yes.
Okay, previously. So R1 is the Bangalore branch. Okay, and suppose R2 is the Mumbai branch, and they are connected using a network 5.5.5.4/30, and here it is, I suppose it might be configured with .5 here. Okay, so let me take, so here it might be configured with .5. Okay, so .5 might be configured with, say, R1 configured with .5, and .6 might be configured in R2 here. Okay, I suppose you don't have any doubts. And here we might have configured with 10.50.100.1 here, and 192.168.200.1 here. Okay, let me just show it to you here. Let me take the console. The router will take some time to come up. Yes, I suppose now it has come up. Okay, so now let me show it to you here. So R1 is configured with the IP. Okay, it needs to come. Yes, show IP interface brief. You can see here it is 5.5.5.5, and this 10.50.100.1 here. So here it is .1, and here it is .5, and here it might be .6, and here also it might be .1, 192.168.200.1. Okay, so R2, let me go and check. R2, if you check, show IP interface brief. Okay, yes, 5.5.5.6 and 192.168.200.1 network. Okay, this is the existing topology. Now, so while checking the R1's routing table, you can guess it will show two routes, or it will show two routes there. So 10.50.100.0 route and 5.5.5.4 route, because both are directly connected networks. Okay, so show IP route. You can see two directly connected networks. 5.5.5.4 is directly connected to serial 0/0, and 10.50.100.0, which is directly connected to fast internet 0/0. Okay, now R2 also the same, only two networks will be there, 192.168.200 and 5.5.5.4. Okay, so show IP route. You can see 5.5.5.4 and 192.168.200.0. Okay, now we are going to implement OSPF. Okay, now let me tell you how to implement OSPF. We'll go to the config mode and we'll mention router OSPF. The command is router OSPF. Then we'll give a value whose value can range from 1 to 65,535, and this value is called process ID. It's called process ID. So it is just to identify the connection. So I can give any value, 100 or 200 or 300, any value I can give. So the value needs to range between 1 to 65,535. So I'm giving 100. Okay. Now, so I'll give you time to write. Okay. Now that I've configured OSPF 100, you can see we have went into the OSPF. Okay, went into the router. It means config-router means we have went into the routing protocol or OSPF. Clear? Then you will mention the directly connected network. We'll mention the directly connected network, which needs to be shared to the other router. Okay, so in static routing, we mention the unknown network. Here we will mention the known network so that it will be shared through the OSPF to the other router. Clear? Okay, so now let me tell you. So here you got two networks, 10.50.100 network you will mention. So you're going to mention in OSPF, you're going to mention something like this, network. The command is network. Then the network address, which is this one, 10.250.100.0. 10.250.100.0. So here you're going to mention that. So 10.250.100.0. Then you will mention the wildcard bits. You will mention the wildcard bits. So if it is /24 here, it's /24. If it's /24, what will be the wildcard mask? Yes, guys. Somebody back was. You are right. Okay. What about you guys? 0.0. 2. Okay. Sure. Okay. So 0.00255. Okay. So you're just now you have found out. So it is 0.0.0.255. Okay, and you will mention the area as well. I've told you the significance of area. So here you will mention the area. Suppose, say, just two routers we have. So suppose everything is in area 0, the backbone area. Everything is in area 0. So then what you will do is that you will mention area 0. Clear? This is what you will do it. Okay. Now it's not complete yet. So we have only mentioned, say, one network here. Okay, 10.250.100.0. You have to mention the other network as well, 5.5.5.4. Okay, so we'll mention, say, the network is, or the network 5.5.5.4. And if it's /30, what will be the wildcard mask? If it's /3. Just now only we have discussed about /30, right? Say for, sorry, not here. Okay, I suppose somewhere around here. Okay, the fourth question. So 0.0.0.3. Okay, so the wildcard mask is here 0.0.0.3. And area, suppose everything is in area 0, so area 0. Clear, guys? Okay, then we'll exit. So do show run section router OSPF.
Here we don't have to write command or no shutdown.
Okay, no shutdown is usually done in interfaces. Interfaces will be down by default, but not the protocol. Okay, yes. So these are the commands, guys. If you want, you can note down the commands. So this is the command in, and you will exit from there. The command in R1. R1. Okay. Now,
The next command.
hmm?
Next command.
Yeah, next command or in the next route. Okay,
Do show.
do so. That is running config only. Okay, this, let me tell you what is this. Where is it? Okay, this means do show run, means show running config. Now you are customizing the running config. Running config will be, configuration will be very much lengthy. You can customize it. So I have put a pipe symbol. I put a pipe symbol, and after pipe symbol I need a section. I'm looking for a section. Okay, so section you can mention. Section router OSPF. Then it will check for the section which is starting with router OSPF, or which contains router OSPF. Okay, that's it. Customizing the running config. That's it. Okay. Now let me tell you. So here, this is the configuration in R1 and R2. So R2 will go to the config mode. We'll go to the config mode. Then we'll mention, yes. So again, just give me a moment. Let me start capturing the packets. Start capture. Okay, now, so let me configure OSPF in R2 now. So in R2 I'm gonna go and configure the directly connected network. Okay, so where is R2? And we'll configure a router OSPF. Router OSPF. Now if you want, you can give 100 or any other values also if you want you can give it. Suppose I'm giving 500. I'm giving 500. Salman. Okay, so router OSPF 500. You have went into the OSPF now, config hyphen router, where you will be mentioning the directly connected networks. So for R2, the directly connected networks are 192.168.200.0 and 5.5.5.4. Okay, and here it is /25 and here it is /30. So let me write it down. The command is network 192.168.200.0. So it's /25. So the wildcard mask will be 0.0.0.127. Okay, and area 0. Similarly, you will mention network, the next one 5.5.5.4.
0.0.
Yes, 0.0.0.3 and area 0. And we will exit. Clear? So now you can see a message. OSPF adjacency change, or you can see process 500 means OSPF 500. The neighborship has created. They have created the neighborship. And the neighborship has now moved, and the state OSPF state is now full, loading to full, and loading done. That means now it is in full state, and so they have formed the adjacency. They have formed the adjacency. So what happened is that, let me tell you, here they will send the hello packets. They'll send the hello packet. So at first it will be in the init state, and then it will be like in the two-way state. Then they will say yes, they'll go in the start, exchange, loading, and finally full. In the full state, or when the adjacency is created, that means all the routes have been shared. Whatever needs to be shared is shared. Clear? Okay. So now, shall we check it in R1? Okay, in R1, if you check it, you need to have this 192.168.200 network in its routing table. Okay, so let me go to R1. So previously it was not there. Previously, when we have checked, it was not there. You might have seen only the directly connected networks. You can see only only two directly connected networks. Now if I check, do show IP route. Do show IP route. So you can see 192.168.200 network. Clear? Okay. So 192.168.200.0 network, and they have got it via OSPF. O means OSPF. Okay. Now you can see 110. Any idea what this value is? Exactly. Very good. It is 80 value. Okay. So this value is called AD value, administrative distance value. So OSPF, the AD value is 110. Okay, now the second value is the coast. It is the coast, or it is the metric here. Getting it? So now for say OSPF, or say for 192.168 or 200 dot network, 74 is the coast. So for R1 to reach 192.168 or 200 network, 74 is the coast. Shall we try to find out the coast?
Yes.
Sure. Okay, so now let me tell you. So R1 here, it is fast Ethernet 0/0. But for fast Ethernet 0/0, let me tell you what is the coast here. For fast Ethernet, it is 1. The coast is 1. Okay, so 100 Mbps is the reference bandwidth divided by the interface bandwidth, which is 100 Mbps. The value is 1. But let me just show it to you what the value here is. R1, you got the command, another command, do show IP OSPF interfaces brief. Okay, I'll tell you the command later. Okay, now let me show it to you. See, so this is R1, and R1's fast Ethernet 0/0 has got a coast of 10, not 1. But why? Let me tell you. Okay, because say you got fast Ethernet 0/0. Okay, so and this is working in Ethernet. Okay, so if you got a link in which one is fast Ethernet and the other is Ethernet,
According to this.
it will work according to, yes,
So that both are same and they can
Exactly.
communicate.
yes. So say the link will be working in the slower speed, which is 10 Mbps. Getting it? Okay, so even though fast Ethernet 0/0 is capable to work in 100 Mbps, they will not work in 100 Mbps because you got a slower link. So this is slower link is 10 Mbps, and so this will be working in 10 Mbps bandwidth, and that is why say the coast has become, so the coast will be reference bandwidth, which is say 100 Mbps divided by interface bandwidth, which is not 100 Mbps, which is 10. So the value is 10. So the coast, sorry, so here the coast is 10. Here also the fast Ethernet, Ethernet. Clear? Okay, so for R2, okay, so actually we should have taken a look at R2 only, right? So let me take a look at R2. It's not R1. We need to take a look at R2. The same thing only. Do show IP OSPF interface brief. So you can see fast Ethernet, and it is 10. Okay, so the coast is 10. For R2 to reach this 192.168.200 network, the coast is 10. Now for R2 to reach R1, for R2 to reach R1, so this connection is the serial connection, and the base bandwidth is 1.544 Mbps. So if it is the serial connection, what will be the coast, guys? 64 will be the coast. Okay, so here you can see 64 in serial 0/0. Okay, so now let me tell you what happens. So here you can see 64 is the coast. Now, so R1 or R2 will send the route to R1. R2 will send the route to R1. It says, hey R1, I know 192.168.200 dot network, and that has a coast of 10. But for R1 to reach R2 itself, the coast is 64. So first it has to reach R2 with a coast of 64, then need to reach this 192.168.200 network. So the coast will be, yes, 64 plus 10, that will be 74. That will be the coast. Clear, guys? Okay, so now let me tell you. So this is the coast here. So you can see, so that is how it has got the coast for R1 192.168 dot, say that network will be, so this is R1. Okay, it is having the coast of 74. Okay, the same thing happens in the next route also. Okay, so here the bandwidth, or the say bandwidth is 10 Mbps. Okay, so if it's 10 Mbps, then the value or the cost will be 10. So using the equation, same equation. Okay, so you will end up in the cost 10. So Smith, Okay, Satish. Okay, so now, so here the cost is 64. So when R1 sends the route to R2, R2 will add the 64. 10 plus 64, 74. Clear, guys? So again, when you check R2, you will have the next route, do show IP route. Again, you can see 10.50.100.0 and the cost is 74. Clear? Okay. So this is how the OSPF works. Now, so here if you want to ping from this computer to this computer, now the routing is done, the ping needs to be successful. Okay, so let me get the IP of PC2 so that you can ping from PC1. Okay, so IP of PC2 is, okay, I suppose we have not configured the IP. So IP, let me configure the IP. Suppose it is 10.250. Sorry, it's 250. 250 dot. Just a moment. 100 dot. Suppose 2. 100.2. Okay. So 100.2/24, and the gateway is 10.250.100.1. Okay, this is how you will set the IP address for this one. I mean the VPCS in the GNS3. Okay. Now the next one, PC2. Let me set it. Say the command is, say this IP is 192.168.200. Okay. So IP 192.168.200. Suppose 2 only. Okay. /24. It's /25. 25 there. Okay. So here it is 25. So /25. Then the gateway is 192.168.200.1. Okay. Suppose everyone is following me, right? Okay. Satish, you look so sad today. Why? What happened?
Actually, I worked on some projects. So
Okay.
I didn't get asleep.
Okay.
Whole day.
No issues. Okay. Let me tell you. Let me pause recording. Okay. So now if I want to ping the second IP. Okay, PC1. Oh. So I'm gonna ping to the second one. So ping, then 192.168.200.2. You should get the reply. Yes, you are getting the reply. So yes, reply from 192.168.200.2. Okay. And suppose if at all you trace route, so trace route or trace RT. Okay, trace RT, then the IP address 192.168.200.2. Okay, trace RT, no, trace route only, I suppose, or trace. Okay, yes, trace. So you can see it has first gone to 10.50.100.1, which is the gateway, which is R1. Okay, then it has gone to 5.5.5.6, which is R2. Then it has gone to the machine. So 192.168.200.2. Clear? Okay. So this is how you're gonna ping, and this is how the OSPF works. Okay. So now again let me tell you some more commands. So some more show commands. So the show command will go to router. Okay. So first show command, I suppose you might have written, say, let me just take notepad. To view the routing table, you already know, right? Say the command is show IP route to view the routing table, and the next command, the command is show IP OSPF interface brief to see the OSPF brief details of OSPF interfaces. To see the brief details of OSPF interfaces. Okay. Yes. Now, to see the descriptive OSPF details, OSPF interface details, you got the command called show IP OSPF interface. Show IP OSPF interface to view the descriptive details of OSPF. Okay. To view the descriptive details of OSPF interface. to view the descriptive details of OSPF interface. Okay. Now the next command. So the neighbor table and the topology table also needs to be viewed. So this command, let me show it to you. Show IP OSPF interface. Okay. So or here do, or the brief details was do show IP OSPF interface brief will let you see the brief details. So if at all you want to see the descriptive details, take away the brief. Okay. Here you can see many descriptive details. Okay. For now, if you won't understand. Okay. It is configured with IP. Okay, so it is serial 0/0 is configured with an IP. This is the IP and it belongs to area 0. Okay, and the process ID is 100, OSPF 100. Okay, now these things and all, yeah, these are the OSPF timers. These are the OSPF timers. Hello timer 10 seconds, dead timer 40 seconds. Sorry guys. Okay, so dead timer 40 seconds, wait timer 40 seconds, retransmit timer 5 seconds. Okay, so these are the timers. So again, you got neighborship. Yesterday I told you EAGRP neighborship requirements. Okay, similarly OSPF also have some neighborship requirements. Only if the requirements satisfied, they are going to form the neighborship. Or one of the requirement is these timers should be same. The timer should be same. Getting it, guys? Okay. Just hold on. Yes. Now. Yes. Okay. Break. Sure. Continue. Okay. So now the next thing. To view the neighbor table. To view the neighbor table, you have the command do show IP OSPF neighbor. Do show IP OSPF neighbor. Okay. Yes. Do show IP OSPF neighbor. Okay, it's NEIGHBOR. Okay, NEIGHBOR. Okay, so you can see I told you R1 will have, say, the neighborship as, or he has already formed the neighborship with R2. So R1 will have R2's information. Okay, R1 will have R2's information. So this is R2. R2 is having the IP 192.160.200.1. Okay, and it is in full state. Means adjacency have been formed. They have shared the roots and adjacency have been formed. Clear? Okay. Now the next one. If at all you want to see the topology table, you got the command do show IP OSPF database. Do show IP OSPF database. Okay, if you check it, but now you won't understand anything. Okay, so here you won't understand anything, just understand what is the command to view the topology table. Okay, so these are the OSPF related commands, and you got, let me tell you one more command. Do show IP protocols. Do show IP protocols. So here you can see do show IP protocols. So it will show you all the routing protocols enabled. Okay, now here OSPF 100 in R1 OSPF 100 is enabled, or OSPF 100 is configured. Now here you can see the router ID, which we will discuss later, and maximum path 4. Okay, that also, suppose the load balancing, if at all the coast is load balancing, it will load balance, okay, with a 4 maximum path. Now you are routing for the networks. That means you are, say, routing, or you are just, say, routing these networks into OSPF, participating these networks in the OSPF, or sharing these networks to the other routers. Clear? Okay. Now, Ashwin. Okay. So these, and you can see the distance is default 110. That means the distance, administrative distance is default is 110. Okay. So these are the OSPF commands. Now let me just tell you one more thing. So this configuration, or so here everything is area 0. everything is area 0. Everything is under area 0. Now suppose you got another router here. You got another router. Let me connect one more router. Okay, R3. Okay, now so let me create a router R3. R3. Now let me connect it again. Say suppose serial 0/1 and serial 0/1. Okay, now here it's 0/1 and here also it's 0/1. Okay, now let me again tell you. Suppose we are setting an IP. We are setting an IP here. Okay, just give me start. Console. Okay, so here we are setting an IP here. Suppose 8.0.0.0/30. So it is 8.0.0.1 and suppose it is 8.0.0.2. Okay, so now you are, so let me set this IP first. Okay, serial 0/1, so 8.0.0.1 and 2. Okay, so here I am gonna go, so interface serial 0/1 and I'm setting an IP address is 8.0.0.1/30. So it's 255.255.255.252. Then I'll be giving no shutdown command to the interface. Okay, so now I'm going to R2 and executing that command. Okay, now going to R3 and again giving another IP which is 8.0.0.2. Okay, now suppose we got a LAN here. We got a LAN. We got a LAN. Where is the LAN? Is he sitting there? No. Okay, so we got the LAN. So now say you got a LAN, or suppose you got a switch and you got some computers. Okay, but I'm not gonna create a physical LAN here. I'm just gonna create a virtual LAN. I'm just gonna create a virtual LAN, or I'm just gonna create a virtual interface. I'm gonna create a virtual interface, or the virtual interface is called loopback interface. It's called loopback interface. It's called loopback interface. Just used for testing purpose. Now that I don't want to like take the switch again, then like connect it, take the computer, give the IP, it's really unnecessary. So I'm just creating a virtual interface which is called loopback interface. So let me create a loopback interface here. So let me go to R3 and create a loopback interface. So, or the virtual interface. Now I'll create a virtual interface like this. Interface loopback. Okay, suppose 1000. I've created a loopback 1000. So now you can see a virtual interface has come up. Okay, so the line protocol of loopback 1000 has come up. Means I've created a virtual interface and I can give an IP to the virtual interface also. Suppose I'm giving an IP like this. Say IP address. Suppose just random IP. Say suppose 172 dot say 32.0.1. 172.30.0.1. 255.255.255.0 or any value /24/25, any one you can give. Suppose I'm giving /30 only, /32. Okay, so this is an interface or this is a network. Okay, so it is 172.32.0.0/32 network. Okay, or sorry 172. So this network is or 172.32.0.1/32. This itself is a network. Okay, because it's /32. Okay, now you can participate this loopback interface also. You can participate this loopback interface also in the OSPF. So what my intention is that, so this was in area. So far we were doing area 0 only, right? So previously we were doing only area 0. This was area 0. Now I'm gonna create area 1 or area 100 or 200 or anything. I'm gonna create area 200 suppose. So what I'm gonna do is that I'll mention this serial 0/1 as area 200. It is participating in area 200. And R3 is entirely participating. Its loopback is also participating in area 200. Its serial device also is participating in area 200. So shall I configure it? Okay. So now we'll go to R2. So we'll go to R2 now and say do show IP protocol. Okay. So you can see OSPF 500 is configured. So I'll go to OSPF 500 itself. Router OSPF 500. Okay, then we'll tell the command network. Network, what was the network here? 8 dot. Okay, the network was 8.0.0.0/30. Right, so I'm gonna give that network here 8.0.0.0, so 0 only. Okay, the network. Okay, then say the wildcard mask, which is 0.0.0.3 and area 200. Now it's in area 200. Clear? So you will give area 200. Okay, then we have configured second router. Shall we configure the third router also? Okay, so we'll go to R3 and we'll create OSPF. So previously in R2 we have already created. Okay, we have already done the same area or the area 0 and all. Okay, now we need to create it. Okay, so router OSPF suppose 600, just a random number. Okay, the pros ID. Then you will give the network. Network, what is the network? 172 dot. Okay, to check the network, do show IP route. So you can see two networks are there. Okay, so 8.0.0.0/30 network is there and 172.32.0.0/32 is also there. Okay, or 172.0.32.0.1. Okay, so what I'm gonna do is that I'm gonna mention it. So here we'll mention the network. Network 8.0.0.0 and the wildcard mask is 0.0.0.3 and area is area 200. Okay, and the next network. So here the neighborship has formed or the adjacency has been formed. Now network say 172.32.0.0. Okay, 0.0 and 0.0.0.0. It's /32 only. Okay, sorry, it's not 0.0. It's 255.255.255.255 and area, say this is area 200. Any doubts? Okay, clear? Okay, so now we'll exit. And what happens is that this R3, so now let me, okay, this R3 is having a network 172.16.0.0 network. Okay, or 172.32. Okay, 32 dot network, not 16, 172 to 32. So 172.32.0.0/network. Okay, this network will be advertised to R2 and R2 will advertise to R1. Now this is area, this network is in area 200. Now it is now in area 0. So area 200 route is now in area 0. Shall we go and check in R1? Okay, so if you go and check in R1, let's see. Do show IP route. Yes, you can see the 8 dot network is there. Okay, the other network is not there. Okay, might be because R3 suppose okay, yes, now you can see it because the IP itself was 172.32.0.1. okay, /32 was the network itself. Okay, so now if you go and check in R1, you can see two routes, okay, with OIA. It's called OIA. It means inter area routes. You can see OIA. O is OSPF and IA means inter area. Inter area means this network it doesn't belong to this area, but it is in different area. Getting it? Okay, so this is say OIA 172.32.0.1, and here it is OIA 8.0.0.0 network. I suppose you are, it's okay for you, right? So this is called inter area. Okay, it's called inter area. It means from one area to another area. So communication from, or the inter area communication. If at all, if we didn't implement this, and if at all we are going with only the same area, that is called intra area. It's called intra area communication. So you have studied intra area as well as inter area, and I suppose you got no doubts at all, right? Okay. So this is how you're going to do the OSPF in inter area and intra area. Okay. Now let me tell you some more things. Okay, so here the inter area routes means, suppose this network 192.168.200 network. So you got, or I told you that, say they will send LSA, link state advertisement. Okay, so LSA, what they send in intra area or intra area networks will be sent as LSA type 1. LSA type 1 message. There are many types of OSPF messages or many types of LSAs. Okay, so intra area routes will be sent as LSA type 1. Now inter area routes, this one 172.32.0. So this is shared as LSA type 3. LSA type 3. Okay, so LSA type 3 means inter area routes. Inter area routes. Getting it? Okay. So this is also the OSPF. Now done. Okay. Now let me tell you some more things here. Suppose I told you that R1, so here the cost was 10. Previously the cost was 10. Then say R1 calculated the cost as 10. If you want, you can change the default cost. You can change the default cost. Now suppose I am changing it to 20. So here it is 64, and for R2, so previously it is 74. 10 plus 64 is 74. Now if you change this value to, say, suppose it is 20, then the cost will be, say, for R2 the cost will be 20 plus 64, that will be 84. Shall we do it, Ashwin? Okay, so now, so here let me go to, so what you're going to do is change the cost. The cost can be changed if you go to the interface. You want to change that cost in the interface, so you will go to FastNet 0/0 interface. Okay, so you will go to R1's interface FastNet 0/0, and IP, the command is IP OSPF cost. Then you're gonna change the cost. So previously, so before changing the cost, let me show it to you. Do show IP OSPF interface brief. The cost is 10, and in R2 do show IP route. Yes, it is having, say, where is it, 74. Okay, now that I'm gonna change the cost, so do show, or sorry, I'm in the interface and I'll execute the command IP OSPF cost, then 20. IP OSPF cost 20. Then if you execute the same command now, you can see previously the cost was 10, now the cost is 20. Okay, now if you execute it here, the command, okay, include this one 10 dot. Okay, so just like going for the IP route command only, means just going for the routing table only, but include this one. That means it will include only that line which contains this one. Clear? So you can see now the cost has changed to 84. Clear? So this is how you will change the cost. I suppose you got, yeah. R1 okay, So R1, here we have changed the cost of R1 10.250.100.0. Okay, and that is why we have checked in R2, we have checked for 10.250.100.0. Okay, any doubts? Okay, so then, so let me pause recording. So the best interior routing protocol, or IGP, I would say it's EIGRP. It is EIGRP. When compared with OSPF and RIP, EIGRP is having the best, or EIGRP is having the best feature. Let me tell you why. So first reason is that EIGRP, the AD value is least. So AD value least means more preferable one. Then the second thing is that OSPF, so every time they need to rerun the SPF algorithm, which is a complex process. Okay, if at all the link fail occurs, they'll have to rerun the SPF algorithm, which is a complex process. Now, considering say EIGRP, if at all a path fails, okay, the secondary path will be stored. The secondary path will be stored. The next best path will be stored. Clear? Okay. So, and then they don't need to run that algorithm, whatever the dual algorithm, they don't need to run. Okay, so it's like say selecting a leader and selecting a backup leader. If at all the leader doesn't come, I don't have to select, or I don't have to go for any elections. I've already selected the backup leader. Clear? So if at all the leader is absent, the backup leader will come as the leader. And the third one is that EIGRP supports unequal cost load balancing. EIGRP supports unequal cost load balancing, while OSPF only supports equal cost load balancing. Now the fourth one is that you can say OSPF, it considers only one value, or it calculates, or it uses only one value to calculate the metric, right? It uses bandwidth. It uses bandwidth to calculate the metric. But say EIGRP, it calculates, or it uses many values, k values. It can use many k values. Say first it can go with either say k1 and k3, the usual one, the bandwidth and the delay. Or if it can be configured in such a way that it will choose reliability, say it will choose load and all to calculate the metric. So multiple factors are say checked to select a best route. So again, EIGRP is better. So these are the reasons that EIGRP is better. Clear, guys? So shall we wind up the class then? So yes, thank you guys. We'll see tomorrow. Just a moment, no one's here. So guys, I suppose everyone, so anyone absent for any days, because I have not been taking the attendance. Okay, so I really don't remember who all were absent and who all were like present and all. If you ask me like yesterday who were all present, even I got no idea. Okay, so I suppose everyone was present. Okay, yes. Okay, so then thank you guys. We'll see you tomorrow. And again I repeat guys, Friday is a holiday. Okay, every day sorry?
We will never forget that.
Yes. Thank you guys. Yeah.